Hi, and welcome to Failurology, a podcast about engineering failures. I'm your host, Nicole, and I'm from Calgary, Alberta. I have over a decade of experience in the field of mechanical engineering in building science, directing the construction of plumbing, heating, ventilation, and air conditioning systems in various high-rise, multifamily residential, and commercial buildings across Western Canada. I love reading about engineering failure case studies, not just the science behind what went wrong, but what we can learn as an engineering community to prevent future failures from happening. Starting a podcast has been a dream of mine for a long time, and it's been a bit of a learning curve. I want to thank each and every one of you for listening, and I hope these stories interest you as much as they interest me. Please check out the link in the show notes of this episode to see photos from this week, and please rate, review, and subscribe to the podcast so more people can find it. This week in engineering news, a 5-year study shows that recycled concrete performs as well, or in some cases better, than conventional concrete. Researchers at the University of British Columbia's Okanagan Campus School of Engineering in Kelowna, British Columbia, compared recycled and conventional concrete on a municipal sidewalk and a building foundation over a 5-year period. They found that after 5 years of service, the recycled concrete had comparable strength and durability to the traditional concrete. Concrete is typically made from a mix of 10 to 15% cement, 16 to 75% aggregate, and 15 to 20% water. The recycled concrete replaces the aggregate used in traditional concrete making. Researchers found that the recycled concrete adequately compared to the traditional stuff and was even stronger after the initial 28-day cure. Waste materials from construction and demolition make up about 40% of the world's waste. Shahriar Alam, co-director of UBC's Green Construction Research and Training Center and the lead investigator of the study, states that a number of countries around the world have already standardized the use of recycled concrete in structural applications, and we hope our findings will help Canada follow suit. Check out the link in the show notes if you want to read more on the study. Now on to this week's engineering failure, the Grenfell Tower Fire in London, England. When the Grenfell Tower caught fire in June 2017, it made the news over here in Canada. I've been loosely following the story ever since, but it wasn't until I dug into the details while researching this episode that I realized there was a much larger conversation to be had about the combustibility of building materials. To be honest, I'm still a little in shock about how this could have happened, and that the Grenfell Fire isn't the first time. But I'm getting a bit ahead of myself. Let's start at the beginning. Grenfell Tower was a 24-story, 67-meter-tall residential tower referred to as a tower block located in North Kensington, West London, in the United Kingdom. The tower was part of a larger complex. There were 3 low-rise finger blocks connected to Grenfell: Barrington Walk, Testerton Walk, and Hurstway Walk. Construction started in 1972 and finished in 1974. The tower was designed in the Brutalist style, which is a minimalist architecture style showcasing the construction building materials over decorative design. Brutalist buildings look very utilitarian and kind of cold. We have a few in Calgary, and honestly, it's not my favorite style. The original Grenfell Tower architect was Clifford Weirden and Associates, and it was built by A.E. Symes. The tower consisted of 120 1- and 2-bedroom flats with 6 dwellings per floor to house approximately 600 people. None of the suite partition walls were structural, since it was designed to be flexible so that floor plans could be easily modified to accommodate more or less suites. Grenfell Tower was part of a public housing complex referred to in the UK as council housing, owned by the Kensington and Chelsea London Borough Council and managed by the Kensington and Chelsea Tenant Management Organisation, which was made up of 4 council-appointed members and 3 independent members. At the time of the fire, 14 of the flats had been bought under a right-to-buy policy and were occupied by the leaseholders or rented out on the open market, but the rest were subsidized. Grenfell Tower housed poorer, mainly ethnic minority residents in one of the wealthiest locations in the country. This is important. We're going to circle back to it later. A major renovation of the tower was announced in 2012 and took place in 2015-2016 with the objective of replacing the substandard heating system, replacing the windows, increasing thermal efficiency of the tower, and improving the appearance. There were several players in this major renovation, but the key ones are as follows. The architect, Studio E Architects, general contractor, Ryden Construction, who carried Harley Facades to replace the building exterior, which I'll be referring to as the building envelope. It should be noted that the renovation work was originally contracted to Leadbitter for £11.278 million, but was instead given to Ryden for £8.7 million. And Artelia completed the contract administration. The renovation project included upgrades to the existing envelope, which would accomplish two of the main objectives: increase thermal performance and improve the appearance. The building was reclad with 150mm external insulation and aluminum composite cladding. Before the fire, a group of residents banded together to form the Grenfell Action Group. Between 2013 and 2017, they published 10 warnings criticizing fire safety and maintenance practices within the tower block, calling out flaws with the tower emergency lighting system in 2005. In 2013, they published a fire risk assessment done by a tenant management organization which outlined the following concerns. Firefighting equipment at the tower hadn't been checked for up to 4 years. Some fire extinguishers were expired, and some had condemned written on them. The Grenfell Action Group also documented numerous attempts to contact the Kensington and Chelsea Tenant Management Organization and the Council Cabinet Member for Housing and Property, but they never received a reply. In July 2013, the Kensington and Chelsea London Borough Council threatened legal action against the resident group for alleged defamatory behavior and harassment. 2 women, Mariam El Ghouari and Nadia Shouker, who were threatened legal action, later died in the fire. In January 2016, the Grenfell Action Group warned that people might be trapped inside during a fire, as there was only one entrance and exit for the tower, and corridors were allowed to be filled with garbage, such as old mattresses. The Grenfell Action Group even went as far to state, "We predict that it won't be long before the words of this blog come back to haunt the Kensington and Chelsea Tenant Management Organization, and we will do everything in our power to ensure that those in authority know how long and how appallingly our landlord has ignored their responsibility to ensure the health and safety of their tenants and leaseholders. They can't say that they haven't been warned." The group also warned about exposed gas pipes in the months before the fire. In 1968, exposed gas pipes exploded at Ronan Point, a 23-story council tower in East London, collapsing an entire corner of the building. Grenfell Tower did not have fire sprinklers, similar to the majority of tower blocks in the UK. In June 2016, an independent assessor found 40 serious issues with fire safety, requiring action within weeks. In October 2016, no action had been taken. In November 2016, the London Fire and Emergency Planning Authority served a fire deficiency notice listing many fire safety issues at the tower, requiring action by May 2017, including fire doors, smoke venting systems, and firefighter lift controls. As you can see, multiple groups flagged multiple issues to the council before the fire, but nothing was done. On June 14, 2017, 50 minutes after midnight local time, a fire started from a malfunctioning fridge freezer on the 4th floor in flat 16 and burned for roughly 60 hours before being extinguished. I want to take a second to mention that the 4th floor was not actually the 4th floor from grade, it was the 8th. Floors from the bottom up went ground, mezzanine, walkway, office, 1st, 2nd, 3rd, 4th, and so on. From what I've read, this seems to be somewhat common in the UK. A call to 999 or 911 in North America went out at 12:54 a.m. By 1:09 a.m., the fire began to penetrate the window frame. Firefighters entered the 4th floor flat around 1:14 a.m. At 1:13 a.m., more pumps and an aerial appliance were requested. The water jet on scene couldn't reach the 4th floor, which remember is actually the 8th floor above ground. By 1:15 a.m., smoke had spread to flat 26, which is the flat above where the fire started. By 1:18 a.m., 34 of 293 residents had escaped. Another 76 would escape by 1:38 a.m., woken up by smoke alarms when smoke entered their flat. I read that the fire occurred during Ramadan, and many Muslim residents were awake and able to alert their neighbors. I'm going to pause the timeline here to point out a few things. First, the building didn't have a central fire alarm. Aside from someone going door to door to notify people, the only way residents were aware of the fire was when smoke entered their suite and set off the individual smoke alarms. And second, the building emergency policy was to shelter in place. That meant that the residents were expected and told to stay in their suites until the fire could be extinguished, which is apparently standard policy in the UK. There were a couple reasons for this. One is that there was only one stairwell to exit, and it was thought it would become too crowded. And since the building was concrete and each unit was fireproofed from others, it was believed that a fire would be contained and extinguished before it could spread. None of these things really make sense to me. You're kind of just asking for trouble here. I can somewhat understand that a central fire alarm system was not part of the building code in 1972, although a publicly owned building should have been upgraded at some point. But the shelter-in-place policy is the really crazy part. I can think of no scenario where sheltering in place would be my plan A. Maybe if exiting was unsafe, but to just sit tight 20 floors in the air and hope for the best without trying anything else? No, absolutely not. No thank you. By 1:27 a.m., fire had reached the roof at a terrifying rate. The fire doors throughout the building didn't close or seal properly, and smoke began to spread from the affected areas into the lobbies. Between 1:30 and 1:40 a.m., smoke entered the stairwell, although it was still passable for another 30 minutes. At 1:42, fire had spread to the north side of the tower after starting on the east side. Between 1:38 and 1:58 a.m., another 20 people escaped, and another 48 people would escape by 3:48. At 2:47, the shelter-in-place order was officially lifted. Later investigators would determine the order was lifted 80 minutes later than it should have been. By 4:44, all sides of the building were affected, and people, if they could be reached at all, were told to self-evacuate. The last resident was rescued at 8:07 a.m. The rescue teams were able to evacuate all residents up to the 10th floor, all but 2 up to the 12th floor, but only 2 people from the highest floor. 72 people died. 70 were injured, and 223 escaped. All of this was preventable. The Grenfell Tower Fire is the deadliest structural fire in the UK since 1988, when the oil platform Piper Alpha explosion killed 167 people. It's also the worst UK residential fire since World War II. More than 250 firefighters, 70 fire engines, 100 ambulance crew, and 20 ambulances attended the scene. The fire affected the 3 low-rise finger blocks connected to Grenfell, which were evacuated for fear the tower would collapse. The low-rise buildings also lost hot water as they shared a boiler system with the tower. The following afternoon, the building was assessed and determined to not be in danger of collapse. In addition to issues with the building, there were also several issues encountered by the London Fire Brigade while fighting the fire. The water pressure was inadequate. A high ladder arrived after 32 minutes, at which point the fire was out of control. The policy has since been updated to send a high ladder to tower fires. Radio communication didn't work, either due to overuse or interference with the concrete structure. Aerial appliances, due to narrow London streets, could only reach 32 meters. A 42-meter platform was borrowed from Surrey, but after the fire had been burning for several hours. The single stairwell restricted access. It filled with smoke an hour after the fire started. To this day, the UK only requires 1 stairwell in towers. In North America, and probably other jurisdictions I can't speak for, every interior space must have 2 points of exit. And in Calgary specifically, a mechanical ventilation system is used to pressurize the stairwell and prevent smoke from entering. The vast majority of UK tower blocks don't have sprinklers. Only 2% of the UK Council and Housing Association-owned tower blocks have sprinklers, even though there's an 87% reduction in deaths when sprinklers are installed. Sprinklers have been required since 2007 in new buildings, but there's no requirement to retrofit. In Calgary, I've worked on some projects where the building owners received government grants to retrofit sprinklers into an existing building during a major renovation, but I don't know if this program exists in the UK. It was determined that the fire spread rapidly up the building exterior envelope due to the cladding, external insulation, and the air gap between them, which enabled stack effect. You may have noticed that I've been referring to Grenfell in the past tense. That's how bad this fire was. While the building didn't fall down, it's expected to be deconstructed by 2022. It's currently covered in a protective wrap for forensic and aesthetic purposes. This is probably a good thing, so no one has to look at it anymore. So what went wrong? Why did the fire spread so fast? The building envelope upgrades included insulation, an air gap, and then exterior cladding. Both the cladding and insulation used were combustible and not recommended by their own manufacturers for use on a building this size. The manufacturer is based in the US, where this product is not permitted on high-rise structures as it does not pass the National Fire Protection Association or NFPA Section 285 testing. But the UK doesn't require contractors and developers to follow NFPA as it's a US code. There is a similar UK code, the British Standard 8414, but even that doesn't seem to be adequately enforced. Even though there had been similar fires before Grenfell, the problems with the cladding and insulation seem to have been overlooked. The cladding used at Grenfell was the Renobond PE model manufactured by Arconic. It is made from two coil-coated 3mm aluminum sandwich plates, fusion bonded to both sides of a polyethylene core. The core is the main issue with this product, as it's combustible. According to Arconic's own brochure, the polyethylene core cladding is only permitted on buildings up to 10 meters tall, or about 3 stories. They also have a fire-resistant core cladding, but that product is only permitted up to 30 meters, or about 9 stories. Above that, the non-combustible A2 cladding should be used. The cladding installation was passed on May 15, 2015, despite warnings that combustible insulation should only be used with cladding that doesn't burn. Several groups, including the manufacturer, said that the cladding shouldn't have been used on a building of this height, yet it was passed by all stages during construction. In North America, under NFPA 285, a mock-up of the entire planned assembly is constructed 2 stories tall with a window in the middle. It's then ignited with gas from 2 different angles for 30 minutes. Flames cannot spread more than 3 meters vertically or 1.5 meters horizontally from the window for the assembly to pass the test. A little PSA. The National Fire Protection Association, or NFPA code, is accessible for free on the internet. You just have to create an account. I use it regularly to look at sprinkler requirements under Section 13, as well as commercial kitchen exhaust under Section 96. NFPA 285, which is the standard fire test method for evaluation of fire propagation characteristics of exterior wall assemblies containing combustible components, is only 35 pages. Yes, the title is long, but the chapter itself is short, and it describes the entire setup and procedure of the test pretty clearly. The test can cost about $30,000, and any changes to the assembly would require a new test. I have yet to find an ACM or aluminate composite material cladding with a polyethylene core that has been able to pass the NFPA 285 test. Based on the sample of information I have from researching the Grenfell fire, in my opinion, the UK government's mandate and testing are insufficient and lack transparency, which I find ironic considering the shelter-in-place order that existed at Grenfell. Mark Harris from Harley Facades stated that, from a selfish point of view, his company's preference was to use a cheaper aluminum composite material, or cladding. The install by Harley Facades of Crowborough, East Sussex was £2.6 million. Alternative cladding with better fire resistance was refused due to cost. The cladding itself wasn't the only issue that caused the fire to spread so fast. There was a standard ventilation gap of 50 millimeters between the cladding and the insulation behind it. Cavity barriers intended to prevent fire spread in this gap were too small or incorrectly installed. This allowed the fire to spread through the gap quickly. The gap also created a stack effect issue. As the hot smoke rose through the cavity and out the top, it created a vacuum of sorts, drawing in cooler, fresh air at the bottom. The fresh air not only helps to feed the fire, but the hot smoke traveling up the cavity also helps to spread the fire. The insulation itself was also a problem. There were 2 types of insulation used at Grenfell, Celotex and Cooltherm. The Celotex RS5000 polyisocyanurate thermal insulation is made up of 150 mm polyisocyanurate foam plates mounted on the existing facade. In 2014, safety experts warned that the insulation was only suitable with non-combustible cladding such as fiber cement panels or the A2 panels mentioned earlier, which do not burn. The insulation was known to burn when heated, giving off toxic cyanide fumes. 3 of the Grenfell survivors were treated for cyanide poisoning. Despite this, the Royal Borough of Kensington and Chelsea certified the tower as allegedly conforming to the relevant provisions. The insulation was more flammable than the cladding. As per manufacturer, when used on buildings over 18 meters or about 6 stories, non-combustible fiber cement cladding, vented horizontal fire breaks at each floor slab, and vertical non-ventilated fire breaks were required, Any changes from this tested configuration will need to be considered by the building designer. None of these items existed or were considered at Grenfell. Cooltherm, a phenolic insulation, was also used. It was never tested with the polyethylene core aluminum panels, the cladding used at Grenfell. According to the manufacturer Kingspan, they would be very surprised if such a system would ever pass the appropriate testing. The local authority building control certificate states phenolic products do not meet the limited combustibility requirements of building regulations. The local authority building control certificate states phenolic products do not meet the limited combustibility requirements of building regulations. One more thing, the new double-glazed windows, mounted in the same vertical plane as the polyisocyanurate insulation, were less fire-resistant than the ones they replaced and too small, contributing to spread between interior and exterior. To recap, the cladding was combustible and not recommended on a building over 10 meters tall. The insulation was not recommended to be used with combustible cladding. The air gap between the cladding and insulation did not contain the necessary cavity barriers and not only allowed the fire to spread, but actually helped it. And lastly, the windows contributed to the fire and smoke spread from the building envelope into the suites. Despite all of this, council building inspectors visited the site 16 times from August 2014 to July 2016 and passed the building. The fact that the fire ever happened is already so terrible, but what's happened since and what's been uncovered is almost as bad. Theresa May, UK Prime Minister at the time, visited the site the day after the fire and visited survivors the day after that. She's been widely criticized for her reaction. Following the fire, there have been several resignations. Conservative Council Leader Nicholas Paget-Brown resigned on June 30, 2017. London Fire Brigade Commissioner Danny Cotton retired early in December 2019 following criticism of the response. The Council Deputy Leader and Chief Executive also resigned. Council had £274 million in reserves in 2017 after years of underspending. Despite this, some residents still had rent payments deducted from their accounts after the fire. The building was insured for £20 million, not enough to cover the direct costs, which are expected to be £1 billion when factoring in litigation, compensation for death and injury, rehousing and rehabilitation, demo and rebuilding, as well as improving and evacuating other tower blocks. There are estimates of at least 600 other private and council UK tower blocks that have a similar cladding assembly. The intent is to start replacing cladding in the buildings of most concern. But the replacement cladding has also failed test. Each individual component was of limited combustibility, and it was assumed, incorrectly, that the assembly would be okay, but it failed the test. At least they're testing it, though. Tower blocks that haven't had the combustible cladding replaced are supposed to have alarm systems and patrols in place to evacuate. In August 2017, a 52-bed trauma unit at John Radcliffe Hospital in Oxford closed for 12 months due to cladding material they had used on that building. In November 2017, Kensington Conservative Party sent a survey to local residents to rate importance of fire safety alongside parking and recycling issues, which is quite tone-deaf. In October 2018, the UK government planned to ban flammable cladding on new buildings over the specified height. The manufacturer literature already says it's not permitted. I'm not sure a formal ban is required, but enforcement of the necessary test requirements by the UK government would definitely be beneficial. On May 9, 2019, Housing Secretary James Brokenshire allocated £200 million to replace cladding on private tower blocks. A fire safety bill, which included provisions for building owners and residents to share information with the fire department related to design and materials used in exterior walls, as well as requirements for regular inspections and sharing of evacuation procedures, was defeated 318 to 188 on September 7, 2020. I don't know what else was in this bill or why it didn't pass, but the government promised the people that they would implement recommendations from the Phase 1 inquiry into the fire, and so far they have failed on that promise. Grenfell has been covered with a scaffolding, protective wrap, and an exterior elevator, which we call a skip hoist. It's expected to be deconstructed by 2022. The government set up a fund to support survivors, but I'm not sure it's enough. Systemic failure of the current building regulation system has resulted in calls on government to cover costs. The fire is also considered by some to be social murder when political decisions led to the preventable death of poor and underprivileged people. I briefly touched on environmental racism in episode 2 regarding the handling of the New Orleans evacuation and rescue operations during Hurricane Katrina, but I want to expand on that a bit more now. Environmental racism refers to the disproportionate exposure to hazards that lead to a negative impact on quality of life. These hazards can be environmental pollution, lack of access to clean drinking water, proximity to toxic waste sites, or in this case, a lack of fire safety upgrades, lack of maintenance of existing life safety systems, and a general failure to address the very real concerns of the residents with respect to their safety. Since the fire, there have been many investigations, some of which are still ongoing. The fridge freezer, a Hotpoint brand under the Whirlpool umbrella, was found to meet all legal safety requirements and did not see a need for a recall. On November 27, 2018, investigating electrical engineer Dr. J. Duncan Glover suggested that non-tightly fitted relay wiring could have caused electrical resistance, resulting in overheating and igniting outer plastic insulation. Electrical power surges had caused appliances to smoke in the past to the point that tenants at Grenfell had received compensation for damaged appliances. The causes of these surges were never determined. While the fridge is what started the Grenfell Tower Fire, the spread is ultimately the fault of the envelope. As much as I agree that fridges shouldn't spontaneously combust, the fire could have started from anything, and I personally don't think that Whirlpool should be responsible for the extent of the damage. Yes, it may be their fault that the fridge caught fire in the first place, but it's not really their fault that it spread so quickly. Police issued a notice to residents that they have reasonable grounds to suspect corporate manslaughter, but a charge won't be filed until after Phase 2 of the public inquiry, which started earlier in 2020 and is still ongoing. The Phase 1 inquiry was completed in 2019, and there's a link on the webpage for this episode. Check out the show notes. As of March of this year, 21 people have been charged with fraud, claiming approximately £1 million in prepaid credit cards, hotel accommodations, and other programs intended for the victims. On June 11, 2019, survivors and victims filed a civil action complaint against Arconic Celotex in Kingspan in Pennsylvania, where the companies are headquartered. Whirlpool was also named for their part in the fridge construction. In an unsurprising turn of events, the manufacturers are fighting this claim, which I somewhat understand from their selfish perspective. Openly accepting liability opens them up to further lawsuits from all over the world, in addition to costs to replace all of that cladding. The manufacturers are blaming the construction professionals for failing to follow regulations. I personally think they're all ethically responsible. The manufacturer for pushing the product, the architect for accepting it, and the contractor for installing it. But who is legally responsible is up to the courts to decide. In September 2020, a U.S. judge dismissed the Pennsylvania case, saying it should be litigated in the U.K. where the fire occurred. Being based in the U.S., the manufacturers would have been well aware of the NFPA 285 requirements, and therefore aware that their product was not suitable for use on towers. Yet they exploited the lax regulations in the UK and the building owners who were trying to save a buck, or in this case, a pound. Lawyers for the survivors showed documentation from all companies explaining how they knew the product was unsafe in a tower application, that it should be kept secret, and that they could exploit people because they didn't understand the test procedure. A representative from Studio E, the renovation architect, told the Enquiry that they hadn't read the UK Building Regulations fire safety advice in its entirety, especially the part about guidance for buildings above 18 meters, although they were aware of it and had referred to it. They also claimed that they were unaware of issues related to combustibility of aluminum composite cladding, which could be a result of a lack of high-rise experience. During design of the renovation, they didn't look seriously into adding sprinklers because Exova, the fire safety expert, didn't recommend them. Specialist packages such as cladding, lifts, and stairs were completed and the primary responsibility of specialist subcontractors. In Canada, the responsibility would depend on where the engineering or architectural stamp lies. For instance, if the cladding package is submitted to the architect with an engineering stamp on it, then the cladding engineer would be responsible for the cladding design and construction. And conversely, if the architect stamped the cladding design on their plans and the shop drawings were not required to contain an engineering stamp, the liability would fall on the architect. Harley Facades claimed they were misled by the manufacturers of the insulation who described it as Class 0 rather than providing surface protection qualities, and Harley didn't have anyone on staff with a qualification in facade engineering. Arconic had provided cladding for a Dubai tower that caused a fire in 2013, but decided to continue marketing in the UK. Harley was unaware of the Dubai fire. Harley also didn't think they could keep costs down with a non-combustible A2 cladding and pushed to use the Arconic product. There are several other fires involving cladding materials, including the 1973 Summerland disaster on Isle of Man caused by acrylic sheeting on the exterior, resulting in 50 deaths. The 1999 Garnock Court fire in Irvine, North Ayrshire, which caused 1 death and 4 injuries. An inquiry in Scotland resulted in a change of the law there, which requires cladding to prohibit the spread of fire. In 2009, the 14-story La Canal house fire in Southwark, London, resulted in 6 deaths and 20 injuries. In 2016, the Shepherd Court fire in West London was caused by a faulty tumble dryer on the 7th floor. And then there's the 2019 Cube fire, a 6-story fire at Bolton University. And that's just the UK. There are so many more worldwide. In Australia, every tower block built in the last 20 years has cladding with some level of combustibility. Malta, Germany, the Netherlands, and the United Arab Emirates all have similar issues. The UAE updated their codes in 2018 to mandate NFPA 285 as a requirement. When I said the Grenfell fire started a much bigger and long overdue conversation, I wasn't kidding. Grenfell was preventable, and it's definitely not okay that anyone died. But the small silver lining here is that the fire uncovered a bigger problem, and the exposure it's gotten could help prevent more deaths. Check out the podcast page, link in show notes, for photos from this week's episode. And if you want to chat with me, my Twitter handle is @failureology. Thanks everyone for listening, and if you're enjoying what you're hearing, please rate, review, and subscribe to the podcast so more people can find it. Don't forget to tune in next week to hear about the Ford Pinto, the car that was known for exploding when rear-ended. Yes, you heard that right. The Pinto exploded when rear-ended. But more on that next week. Bye everyone. Talk soon.